All right, so today we're going to start talking about order of operations, right? So I know you guys have done this a lot, but it's a good thing to always get refreshed on, right? One of my goals as a teacher is when you see those posts on like Instagram and Facebook of like, what's the answer to this problem, that you don't get it wrong, right? I'm sure you've all seen those floating around at some point. So, let's go back over what the order of operations are. So you've got P4 parentheses. All right, E for exponents. M for multiplication. D is division. And remember, multiplication and division kind of go together. You have addition and subtraction, right, which also go together. Remember that for multiplication and division and addition and subtraction, you do those in order that they appear from left to right. All right, so those multiplication, division, addition, subtraction tend to be where most mistakes are made. All right, but overall, this is familiar to everybody? Yes, kind of, sort of. Even if you don't totally remember how to do it, that's okay. We're going to do some examples together, or at least one example. All right, so according to order of operations, what's going to be the first place we start at? Yep, 3 plus 4. Right, so again, you need to do your parentheses first, so that's going to be our 3 plus 4. So that's going to be 5 times, it's going to be 7 squared. All right, I'm actually going to drop those parentheses. Oh. If I could erase stuff, that would be great. Didn't want to do that in yellow. There we go. Okay, so then what's next? Exponents, right? So we're going to do our 7 squared and our 3 to the third. Right, so we're going to do our exponents next. So that's going to give us 5 times 49 minus 3 to the third. Right, so 3 times 3 times 3 gives us 27. Right, and then over 11 minus 2. Okay, so when you've got an order of operations problem set up in a fraction like this, you kind of want to work with the numerator denominator separately, and then just kind of leave it as a fraction rather than think of that as a division necessarily, because really it's like putting that whole top part in parentheses, so you're going to do it for, like, put them both in parentheses, do them separately. And in Algebra 2, we're going to do most things in this format rather than like stick a division symbol kind of in the middle, unless we need to. But all right, so on the top, what's next? Yep, 5 times 49. All right, so we're going to do our multiplication. So that's going to give us 245. Yep, minus 27. And then you've got 11 minus 2. I'm kind of all over the place already. It's only day 1. Over here. All right, so I'm kind of going this way. All right, and then you're going to do those 2 subtractions. Right, so then 245 minus 27 is going to give you 218. And 11 minus 2 is 9. Right, so in algebra, especially algebra 2, we like improper fractions. Right, because more than likely, you're going to have to keep working with that fraction at some point, and rather than have to like put it in a mixed number and then put it back in an improper fraction to do anything with it, it just saves you and I a lot of time. I always want you to reduce it when you can. So if your numerator, denominator are divisible by something, you need to simplify it. But this is as low as it gets. So, and again, I will get you guys calculators here in a little bit, but the calculators can simplify this stuff for you too. So if you're not sure, you can just easily double check it. So we like improper fractions. I know some of you don't, but you're going to learn to like improper fractions. What? We love fractions. No, it'll be all right. We'll get the hang of it. We use a lot of them. So, okay. Any questions about order of operations? Does this kind of feel fairly familiar to everybody? Everybody feel kind of okay about it? I know it's been a while, but probably a long time, really. So. Yeah. Yeah, so like you're going to so if you have several operations inside your parentheses, like within those parentheses, you're then going to follow your order of operations in there as well before you move on to the bigger picture. If that's a good question. All right, any other questions? Man, it's day 1 and we're already asking questions. We're off to such a good start. The next part that's on page 3 there is algebraic properties. Those are important and good to know, but I'm not going to spend a lot of time going back over them. The biggest one is the distributive property where we multiply stuff through, but I'm going to, as we learn some more stuff tomorrow, we're going to do examples with that. So I'm going to incorporate those kind of as we go, just to kind of save us a tiny bit of time. But the other major thing I want to go over today is our properties of exponents. Those are in that chart on the bottom of page 4 there. But we're going to spend some time working with exponents today. All right, so how much do you guys remember about exponents? Like, do you remember any of the rules for them? Or how to apply them? Remember what an exponent... All right, let's start back. Do we remember what an exponent is? Right, but what does that tell us to do? Right, so if it's like 2 to the third, you're going to take 2 and multiply it by itself 3 times. So it's like 2 times 2 times 2. Okay, so we've got that much down. All right, I'm just trying to... I'm just trying to gauge where we are, right? We're starting, as I said in class, or like starting at the beginning, building blocks. We're like working our way back up. We're taking baby steps. So I'm just trying to figure out how many baby steps we got to take. So off to a great start. Okay, so the first one we're going to talk about is the product rule. Right, and so that's for when we are multiplying two things together that have exponents and that have the same base. So, for example, let's say we have 2 to the third times 2 to the fifth. Right, so they both have a base of 2. So your big number is your base, right? Since they have the same base, when we multiply them together, we're just adding the exponents. That's what the product rule tells us to do. So that would be equal to what? Nope. The base stays the same. We only add the exponents. So 2 to the 8th, yeah. Yeah, so the base doesn't change, just the exponents do. Right, because like we were just saying as we do exponents, so 2 to the third is 2 times 2 times 2. 2 to the fifth is 5 2s. I'm not saying 2 that many times, right? But we're multiplying those together, so it's really just we're taking 2, multiplying it by itself 8 times. So that's why we add the exponents. Right, I'm going to erase all my 2's so I have more room. Okay. Product rule? Good, bad? Feel okay? Seem familiar? All right. The next one is our first power rule. So we have 2. So this is power rule 1. All right. I don't really care if you can differentiate between like which one's 1 and which one's 2 as long as you know how to work them both. So this means that when you're taking something that has an exponent and you're raising it to another one. So say we have x squared, but we're also going to take that to the third power. So that means we're going to do x squared times x squared times x squared. Right? When you do that, you have to multiply your exponents together instead of. So like when you're taking a power to another power, you have to multiply. Right, so in that example I have up above, if we have x squared to the third, what would that be equal to? X to the 6th, right. All right, especially those of you at the back. Can you see that okay? Like, am I writing big enough? Okay, cool. Like I said, trying to get the hang of it with the TV. So, make sure everybody can see. All right. So then let's go to power rule number 2. All right, so this one is when you've got kind of more than one thing in your parentheses, kind of like in power rule 1. So there we have like x squared to the third, but let's say we have 3x squared to the third. Right, this one tells us that we need to kind of take that exponent and apply it to everything that's inside. So it's kind of like a distributive property for exponents. So we've got to like still multiply it here like we learned from that last power rule, but we also need to take our 3 and raise it to the third power as well. So it's going to be 3 to the third x to the 6th And then you want to work out what 3 to the third is. So you've got 3 times 3 is 9, times another 3, 27. X to the third. Right, so when you've got something in parentheses with an exponent outside like that, you need to apply it to all of your coefficient and to your variable. Yes?
Why did X go back to the third power? Why didn't it say?
Oh, it didn't. It should be a 6. Good catch. Yeah, no, you're right. It should be to the 6. All right, and as I think most of you remember, I will mess up writing stuff sometimes, so if you catch it, please let me know or ask. Especially because I also get like brain foggy after lunch like you guys do, so. All right. Okay, so for this one, you want to distribute your exponent to everything inside. Okay, the next one is the quotient rule. Right, so this one's very similar to the product rule that we did. So it's when you are dividing things that have the same base. And you will then subtract your exponents. So if we have x to the 8th divided by x to the 5th. Right, you would subtract your exponents, so you're going to subtract the bottom one from the top one, so 8 minus 5 would give you, 3, x to the 3rd. Okay, and the last one is the 0 exponent rule. Anybody remember this one? If you have anything to the 0 power, what's it equal to? 1. Right, so if you have x to the 0, it's going to equal 1. If you have 5 to the 0, it's going to equal 1. If your exponent is 0, it's always equal to 1. All right, do we have any questions so far? I'm sure some will come up as we work through problems. But yes, Abby.
On the quotient rule, what would you do if you didn't have the variable there? Like if it was just like 5 to the 8th power minus, or divided by 5 to the 8th power, like would it be the same?
It would be the same process, yeah. So you would still, so you said 5 to the 8th and 5 to the 5th? Yeah, so you would still make it 5 to the 3rd, and then you could work that out. Yeah, so it applies to numbers and variables. So, all right, good questions. All right, anything else?